A healthy solenoid coil on this loader reads about 9.8 ohms. A dead one reads open. 1 meter, 1 twist of the dial, and a whole class of no-start faults is ruled out. So how far can you actually chase a dead circuit on a Bobcat W90 with just a multimeter? And where's the honest point where you stop poking and go get the wiring diagram? That line is real. Cross it with guesswork and you'll buy parts that were never broken. Start where the machine's already talking to you. The hour meter display doubles as a code display. It shows numeric service codes. If more than one is present, they scroll, one after another. That scrolling matters more than it sounds. Most people read the first code and stop right there. The first one isn't the ranked answer, it's just first in line. Watch the whole loop. And here's what trips up good mechanics. Never guess what a code means. Not once. These aren't a puzzle you decode. There's no rule about what the digits after the dash mean. Code systems change between machine generations. A legend you invented on one loader lies on the next. The factory table gives every code an exact sentence. Look yours up, every single time. Example, free 9 is battery voltage low. Not check the battery, a specific condition the controller measured. That distinction is your whole strategy. The controller reports what it saw, not what's wrong. Now, before you touch a single sensor, do the thing almost nobody does first. Check your grounds. The manual is blunt about it. Corroded or loose grounds cause these symptoms. A bad ground never fails cleanly. It fails like a charger that only works at one angle. Everything's fine. Then you hit a bump and 3 unrelated things go stupid at the same moment. That's the signature. Not one dead circuit, a scattered handful with nothing in common. Nothing in common except the ground they share. Find the thread, not the symptoms. And here's the single most useful thing your meter does on this machine. It isn't resistance. It's voltage drop. Resistance on a ground strap will lie to your face. A corroded joint can read near 0 ohms sitting still and still choke the second it's loaded. So test it alive. Meter on DC volts, 1 lead on the ground point, 1 on battery negative. Then make the circuit work. Crank it, run the fan, put a real load through it. A good ground shows you almost nothing. The reading barely lifts off 0. That's clean. If real voltage is sitting across that strap, the strap is eating it. There's your fault. Voltage on a ground path is voltage the load never got. That's the whole idea. If that just changed how you'd chase a fault, that's exactly what this channel is for. Stick around, because the same trick works on the positive side, and that's where it really pays. Put your leads across a connector, a fuse holder, a splice, while the circuit is working. Whatever voltage shows up there never reached the thing you're trying to power. That's how you catch a bad connection that still passes a continuity test. Plenty of them do. Speaking of continuity, fuses. The manual says if a fuse is in doubt, pull it and check it. Don't eyeball it. A cracked element looks perfect through that little plastic window. But a blown fuse is never the end of a job. It's a symptom with a cause. The wording is careful. If it's burned, find the cause, then repair or replace. Cause. First, drop a fresh fuse in and walk off, and you'll be back under that rear door next week. Now the charging side, because low voltage fakes almost every electrical fault on this loader. This machine runs a 90-amp alternator, and there's a fuse for it in the fuse panel. Check that fuse before you condemn the alternator. People replace charging systems that were only fused open. The manual's low voltage test walks you through it, starting with disconnecting the alternator's B+ terminal. There's a belt check in there too. Worn or deteriorated, replace it. Slip reads like failure. And weak charging shows up in the codes as battery voltage low. Round and round you go. Now sensors and switches. This is where a meter earns its keep, if you read carefully. Look at how the factory table words them. Seat bar sensor short to battery. Seat bar sensor short to ground. 2 separate codes, 2 different physical failures, 1 sensor. The controller already split them for you. Short to ground means that wire found metal. Short to battery means it found power. That's not a decoder ring, that's just the plain English the factory already wrote down. And it aims the meter for you. A wire on ground shows continuity to the frame. A wire on power shows battery voltage sitting there with the key off, where there should be none. Same story on the handle lock and pedal lock circuits. Both failures listed separately by name. Wiggle the harness while you watch the meter. Faults that hide from a still test show up moving. Now the solenoids, and this is my favorite check on the entire machine. Ohms across the coil terminals. That 9.8 figure is the spec at room temperature. In range, the windings intact, wildly high or open, and the coils finished. Done, no argument. Then the second half, which the manual spells out. Feed the coil 12 volts directly. You can see it move. You can hear it. That's a solenoid proven working with the controller out. Now you know something big. The part is good, so the fault is upstream. Signal or supply. And that's when a code like fuel shutoff solenoid open circuit stops being scary. Open circuit means the controller pushed and felt nothing come back. Coil, wire, or connector. You already proved the coil, so it's the wire or the connector, 2 suspects, not 20. Which brings us to connectors, the failure nobody finds because nobody actually looks. The manual has you confirm the controller connectors are locked into place, not seated, locked. Then check the pins for pins pushed back or bent. That's the exact wording it uses. A pushed-back pin touches just enough to test fine, and just little enough to drop out warm. You have to put a finger on each one. There's no meter reading for almost touching. All right, here's the line. Here's where a meter alone genuinely stops being enough. 1. When the code points at the controller talking to another module, not at a part. There's a code for the ACS not communicating with the Bobcat controller. That's a network problem. You can't chase a conversation between 2 boxes with 2 probes and a hopeful attitude. 2. When a code says sensor supply voltage out of range, that supply feeds more than one sensor. Without the diagram, you don't know which ones share it, and you'll test the wrong sensor all day. 3. Any fault living in a splice. Splices are invisible in the machine and obvious on paper. And 4. The honest one. When you've been at it 2 hours and you're just probing, hopefully, the diagram isn't the advanced move, it's the cheap one. It turns a hunt into a short list. So, read every code that scrolls, look each one up, prove the grounds, prove the coil, then open the diagram. Do that, and most electrical gremlins on a T190 turn out to be a ground, a pin, or a fuse doing its job. Subscribe if you want the next one, the hydraulic side, and why the main relief gets blamed for problems it never caused. Exact specs and the full code table are in the service manual linked below. Like this, if it saved you a guess,